Hello everyone. I am Kush from National Institute of Technology, Karnataka, Surathkal. I am currently pursuing BTech in Computer Science and Engineering there. Today we will be discussing about Exemplar of NCERT of the chapter 1, that is of physics, that is electric charges and fields. We'll be directly starting with the questions, MCQ 1. Let us first read about this question. If we go through this question, it is saying that in figure 1.1, two positive charges Q2 and Q3 are there. We can see Q2 and Q3 are there, and fixed along the y-axis. Exert a net electrical force in the plus x direction. Okay, here on the charge Q1 fixed along the x-axis. Okay, if a positive charge Q is added at x0, the force on Q1. Okay, so see what is happening. Two positive charges Q2 and Q3 are there. They will be exerting force on Q1 here, and Q3 will be exerting force from here. See what is happening. This is the diagram. Q2 is here, Q3 is here, and Q1 is here. So Q2 will exert force in this direction. Q3 will exert, just a second. Q3 will exert force in this direction on Q1. Now what we are doing, we are giving a capital Q charge here. So now we have to find out the force on Q1. See, net electric force in the positive x direction. So due to Q2 and Q3, this y direction component is already balanced. As it is also mentioned, that exert net electric force in the positive x direction on the charge Q1. So y direction force is already balanced. Now Q2 and Q3's y direction is no more. Only along the positive x direction is there. So one of the guesses we can take is Q1 is negative. Since both this one is positive, this one should be negative, so that the direction will be along towards them. Next is Q is a positive charge. Okay, positive will again attract, so the net direction of force will be in the x direction only, and is added at x0. Find the force on Q1. Shall be increasing. Find the force on Q1. Okay, shall be increasing along the positive direction. Obviously, okay. The net force will be along x direction. It is confirmed. Shall increase along the positive x direction as we come closer to the x direction. Here, okay. One more thing. If we come here, the net force of this one will be till here. The force will keep on increasing. When we will come here, the net force will be towards this one and this one. So this will cancel. Only the force of this one will occur. When we will reach here, the plus will give in this direction. Negative, this plus will give in this direction, and this positive Q will give in this direction. So after this point, till this point, the force will keep on increasing, but as it just crosses x equal to 0, it will keep increasing. So we have to find such an option. Shall increase, but the direction changes because of intersection of Q with Q2 and Q3. Okay, shall point along the negative x direction. Shall decrease, shall decrease along the positive x direction. This one we can say, shall decrease along the positive direction. Okay, so next, moving on to the next question. That is 1.2. A point positive charge is brought near an isolated conducting sphere. The electric field is best described by. Okay, let me just remove this. Just a second. See what is happening. There is a isolated conducting sphere. Pardon me for the bad drawing. This again we have brought a positive charge here, point charge. Okay. Electric field is best described. So what we know, an isolating conducting sphere can be replaced by a single point in case of electric field. Okay, this direction makes sense, but it doesn't make sense because see what will be happening. These two can be replaced, and along this line can be same. So there should be at least a line. So this one is line, this one is line. So 3 and 4 is definitely not, because there should be a constant line. Again, now depending on, see, and positive charge is near. Okay, positive charge. So let us consider both as positive. So positive charge. Let us, the best way of doing this is, okay, is 1 and 2 same? Okay, one more thing. This one, net electric field is 0, will be always 0. So the number of lines incoming, the number of lines outgoing should be same. So 2 cannot be there, obviously. So I think the option should be 1. Option should be A. Electric flux through the surface A, surface A in the figure 1.34 is the largest. Okay, in the figure 1.3 is the least. Okay, the flux, what is flux? So flux is the an amount of electric field crossing per unit area. If the area increases, flux should decrease, given that the charges are same. Okay, so fourth is the largest, 3 is the least, 2 is same as figure 3 but is smaller than 4. It is same for all the surfaces. See, when you are inside, it doesn't depend on the surface, it depends on the charge crossing per unit area. So see, the electric lines will be same only. I think you got the point. This is a very tricky question. You always try to remember that it doesn't depend on the type of the surface. If we have an answer, let's just check. Okay, we don't have an answer to this, but yeah, I think this should be the concept behind this. It is always same. Moving on to the next question. 5 charges Q1, Q2, Q3 and Q4 are fixed at their position as shown in the figure 1.4. Okay, there are 5 charges. As is the Gaussian surface as goes slow. Yeah, because of this goes slow. Yeah, I want to say that only. I was pointing this only in the previous question. It is a net Q enclosed by epsilon. So number of charges enclosed by this one. So the electric field flux is what? Q enclosed by epsilon into, yeah. So here everyone is enclosing same amount of charge. So that's why, because of this goes slow, the flux is same for all. Which of the following statements is correct? E on the LHS of the above will have a contribution from. Okay, so Q enclosed is what? If we zoom out, I think only Q2 and Q3 are there. Only Q2 and Q4 will be contributing towards the E, and rest all won't be contributing. Q2 and Q4. E on the LHS of the will have a contribution all the charges, while Q on the RHS will have a contribution. Yeah, that's a good point. E will be from all the charges, but it will be Q on the right side is Q epsilon naught, Q enclosed. So it will be only having Q2 and Q4. Yeah, no, the outside is the net electric field due to the flux. So it will have contribution from all, but it will likely only depend on RHS Q enclosed. See the beauty of the go slow. Here we can see the beauty of the go slow. See, the whole electric field we can determine only by the looking at the Q enclosed. The figure 1 says electric field lines in which an electric dipole P is placed as on. Which of the following statement is true? Okay. Is the same along the direction? Okay. I can see these all are parallel. If it is not parallel, then it will, see, force won't be executed. First of all things, it will execute a torque. That is the most important thing of a dipole. Dipole always gets a torque, not an electric field. So I think dipole won't be experiencing any force, since I think all are parallel also, and force is nowhere in dipole. We have point charge plus q is placed at a distance d from an accelerated conducting plane. Okay, we have to draw this. So let me just remove this quickly. Um, so what is happening? A point charge plus q is placed at a distance. Point charge is plus q is placed at a distance. Is placed at a distance d from an accelerated conducting plane. The field at point P on the side of the C. The field is the point P on the other side of the plane. Okay, fine. See, because of this, how will the electric fields will be directly towards it. Field is point P on the other side. Is P just in front of Q? Then it will be towards outwards from the plane, obviously. Directly perpendicular to the plane and away from the plane. Yeah, I think this should be the right answer. A hemisphere is uniformly charged positively. The electric field at the point on the diameter away from the center is directed. Okay, hemisphere. There is an hemisphere. See, electric field at the point on the sorry, it is charged on the diameter away from the center is directed towards the. Yeah, this can be replaced by this. So it will be towards the perpendicular to the diameter. Yeah, it is perpendicular to the diameter. If you perpendicular to the diameter, it is same. Okay, let us at any point on a diameter, at a point on the diameter away from the center. Okay, here. So here the intensity of this one will be less, this will be more. So they will guide more, they will guide less. So it will be somewhat in this direction. So it will be at an angle tilted away from the at an angle away from the diameter. Yep. I think this should be the right option. Moving to the next. If the flux, this is called flux, if surface is then net enclosed charge is 0. Electric field inside the surface on is 0. Yeah, this can be said. Electric field inside the surface is necessarily uniform. Yeah. The best option. Okay, MCQ. I think this has more than one option correct. MCQ 2. Okay. I think this is necessary to the number of flux entering must be equal to the number of flux, and this is also true. So it has more than one correct. This I'm definitely sure of. Okay, we have option of writing here also. We can say C is correct, D is correct. Electric field inside the surface on itself. We can say this, but it is a conditional statement. So I am very much not sure about this. It will depend on two situations. See, electric field inside the surface on its is 0. See, on the surface it might be 0. Depends on the surface. Inside the surface is necessarily uniform. Okay, it is throughout the surface. Yeah, uniform also you can say, or 0 also you can say. But it depends on the number of flux lines. It is always depends on the number of flux lines. So we can say this thing. The electric field at a point is always continuous. Yeah. Continuous if there is no charge at that point. Yeah, no, continuous is there. Discontinuous there is negative charge at that point. Discontinuous is no. Always continuous. Yeah. If there were only one type of charge in the universe, then not equal to 0. If the charge is outside the surface, EDS equal to 0. Yeah, this one will be correct. If charge is outside the surface, this one will be correct. This could not be defined. No. Consider the region inside. There are various types of. Consider the region inside. Consider region inside which there are various types of charges, but the total charge is zero. At point outside the region, consider region where there are various types of charges, but the total charge is zero. Okay. At a point outside the region, the electric field no, it's not necessary to be zero. Your position can be changed. Na? Reason it is saying, it is not saying a point. So here can be plus, here can be minus. Yeah, dipole can be there. The dominant electric field is 1 by q for large R or R. So, yeah, so this they developed close path away from the region. Yeah, this one will be always true since various types of charges, but the total charge is zero, so it will be only due to dipole. How much plus is there, how much negative is there, and dipole is electric field is 1 by r cube or 1 by r square. Just check it out, but a won't necessary. Refer to the arrangement of the charge in figure 1.6 and the constant surface of radius r with q at the center. The total flux is okay. The net total flux is near charge enclosed to q minus 2q is equal to minus q by epsilon naught. So this one will be correct. The field on the surface E into 4 pi r square equal to q 4 pi r square. Yep. See. Yep. The flux on the surface due to 5q is 0. Okay, 5q is there. Okay. Flux on the surface of due to 5q is 0. No, we cannot say the flux through the surface of sphere. We cannot say this. Okay, minus 2q is severe. No, this one also we cannot say. These two are wrong options. A positive charge q. See, flux is how much lines are crossing per unit area. So it should be uniform. Because net 2 minus 2q won't be there. And for 5q, see, it is outside. So it should be inside thing. A positive charge q is uniformly distributed along the positive charge q is small charge q net force will be 0. Okay, if q is greater than 0, it is equal from the fine, no worries. If see positive charge q is uniformly distributed along a circular ring of radius r, okay, plus q is there. If q is positive and if q is positive, we have if displaced here, it will repel here, so it will do an SHM. But if q is negative, it will attract with more and it will just exit this loop. It will push back toward the center. Yeah, it will never return to the center and will for less than 0. I don't know. For less than 0, we cannot say. For no, q at the center of the ring is in unstable equilibrium. Now it is in stable equilibrium. It will return to the this one, and q less than 0 is displayed away from the center of the ring. It will for q less than 0, if we take out of the plane, so hole will try to attract it. But once it's inside, it will try to be pushed back. So q less than 0, this bit confusion because it will never return to the center and will never return. Actually, it will try to close this part once. It will be displayed away from the center of the ring. This one is sure. It will never return to the center. It will continue moving till it hit the ring. Okay, till it hit the ring. Okay, yeah, this one's correct. Till it hit the ring, it will be moving. After that, this problem. These two are correct. Next is VSA. Let's move on to this. An arbitrary surface enclosed a dipole. What is the electric force? Electric flux is 0 since dipole has one positive. see if we come. Let me just remove all this thing. See, what about a dipole is that dipole has one positive and one negative. So if the whole dipole is enclosed within the surface, so the net charge inside the surface is zero. You're getting my point. So the net charge inside the surface is zero. That means that Q enclosed is zero. So flux directly depends on the Q enclosed. See what is happening? This is the surface, and then there is dipole. Dipole means one plus and one minus. One plus and one minus is there. So Q enclosed is zero. So one plus, however it might be in the Q enclosed is zero. And flux directly depends on Q enclosed. It is Q enclosed by epsilon naught. So flux will be equal to zero. Yeah. And the next is metallic sphere. Cell has an inner radius R1 and outer radius R2. Charge is placed in the center of the spherical cavity. Okay. What is the surface density on the inner surface? Okay, fine, very easy. Surface density is what? Electric charge. As per it is electric charge E divided by area. So E is kq by r square, E equal to kq divided by r square. And the inner radius. So what will be the flux? Will be q divided by r square, that is kq divided by r square all divided by area. So 4 pi r square again. Pi r square again. This real charge density on the inner and outer surface. Yeah. What will be Q enclosed divided by epsilon? The dimension of an atom of the order of an astronaut. Astronaut is a naught. It is 10 to the power minus 10 meter. Thus there must be large electric field between the protons and electrons. Why then there is electrostatic field inside a conductor? Zero. Because of same thing, plus minus. Dipole is there, plus minus is there, net positive equal to next negative. So that's why the electric flux is zero. That's why the electric field inside a conductor is zero. If the total charge enclosed by the surface is zero, does it imply that the electric field everywhere on the surface is zero? No, it is not necessarily zero. It might be uniform. Conversely, the electric field everywhere on the surface is zero. Yeah. If electric field is zero, so the flux is obviously zero. So net charge inside the surface is zero. This one is very good question. The electric field can be uniform, not zero. Zero is not necessary. It can be uniform. Conversely, if net electric field is zero, this one is true. This one is true, but this one is not true. In this case, the electric field lines for a uniformly charged hollow electric. Oh no, boys. This one is very easy. See, for plus, it will be like this. It will be throwing away. It will be again throwing away. For this plus, it will be throwing away. And if you are worrying that this plus is also throw away, na? This plus is also throw away. Next is 1.19. What is the total flux through the faces of the Q? What is the side length is? Okay, total flux is Q epsilon. See, flux at any throughout the surface is Q enclosed by epsilon. Okay, Q is placed at A. Q enclosed means it should be inside center of the face of a Q. What can we say? If we consider a little bit bigger charge, so half will be there, half will be inside, half will be outside. In A, 1/8 will be inside, 1/8 will be outside. So that can be then that in point A, Q by 8 will be inside. Q by 8 will be inside, so Q by 8 divided by epsilon. B in B, Q by so 4 sides cube na. Q by 4 will be inside, so Q by 4 epsilon. C, Q by 2 will be there, Q by 2 epsilon. In D also Q by 2 epsilon. These are things we can say, yeah. But it depends, like if you are considering point charge, then it will be 0. If you are considering a little bit cubic charge, so it will be according to I said. Next is short answer. Paisa coin is made of AI and Mg alloy and weighs 0.75 gram. It is a square shape and its diagonal measures this. Okay. Too many information. Let me write in. Yeah, let me write it. It has a square shape. Diagonal measures 17 mm. This one is 17 mm. It measures 0.75 kg. It is electrical neutral and contains equal amount of positive and negative charges. Treating the Paisa constant equal number of positive charges. Find the magnitude of equal number of positive and negative charges. What conclusion do you from this magnitude? I didn't got this one. Like it has some dimensions. It is electrically neutral and contains equal amount of positive and negative charges. Treating the Paisa made up of only aluminium. Find the magnitude of equal number of positive and negative charges. The Paisa is made up of aluminium and magnesium. It weighs this one. It has a square shape. Treating the Paisa coins made up of only aluminium. Find the magnitude of equal number of positive and negative charges. This is related to ionization because aluminum has no point to say here. As we say, aluminum is +3, so thus it indicates to ionization because +3 electrons or -3 electron. So this can be the answer that -3 electrons should be there. According to weight density, 0.75 kg divided by 4 pi r square. This question can be looked upon. I am a bit worried about, like, the answer should be 0 only, but I am a bit worried about the aluminum side of thing because it is related to the might be related to the ionization of aluminum, that is +3. So the net charge on the whole board should be -3e to make it electrically neutral. And how much -3? See, charge we know, and we know that how much charges it will require. So 0.75 gram divided by 17 millimeter square. 4 pi r square directly we can apply. So there can be a case. Next question, consider a coin of example 1.20. It is electrical neutral, contains equal amount of positive and negative charge or magnitude. Okay, the magnitude. Okay, got it. Okay. Here aluminum is +3, so yeah, I thought only -3. So yeah, it is related to that only. Suppose that these equal charges will be considered into point charges separated by. Okay, find the force now. Force is what? Electrical QE. So the net force always will be, E on the surface is 0 because flux is 0. Net force should be equal to 0 on any point in the surface unless and until we inject some Q by r square. Now equation is 1.22. Represent a crystal unit of cesium chloride CaCl, and then represent by open circles as shown on this one. Located at the corners of the Q of side 0.4 nanometer. Where Cl atoms is situated in the center. Okay. Cs atoms are deficient in one electron, while Cl net electric field on the Cl atom due to the 8 Cs. Okay, net electric field. Q enclosed is okay. Q enclosed won't work here. Net electric field will be 0 because from all direction it is coming same only, so it will be 0. Suppose the Cs atoms with the coordinate A is missing. Okay, this one is missing. So along this line, the force won't be balanced. So it will net force on series. It will be see, this will cancel out this one. This will cancel out by this. This will be cancelled out by that one. Got it. So it will be along this direction, and the force will be kq by r square, and q is 1 electron. Two charges q and minus. Okay, and this one also there can be case it might be q and q by 8 because only 1/8 of the atom is inside. So check according to the options that q by 8 is there or only q is there. Two charges q and minus 3 are placed fixed on the x-axis, separated by distance. Where should a third charge 2q be placed? It doesn't exist. Okay, 1 by third. Okay, inversely depends on the if there is no photo. Okay, fine. This we can do. Let me clear up all those things. Kq divided by r1 square must be equal to k 3q divided by d minus must be equal to d minus r1 का square. ठीक है. So 3r1 square d minus r1 divided by r1 equal to root 3. ठीक है. r1 root 3 1, तो answer should be d r1 equal to d divided by 1 plus root 3. Root 3. So yeah, from small q. Okay. Here shouldn't be d minus, it should be d plus. Let me tell you the concept. 1 second. Net force should be equal to 0. Here plus q is there. Here minus 3q is there. So if we place any charge here, let us suppose we place here plus, it will force this side. Again, 3 will also, minus will also attract this side. But if we place here, plus will give this side, minus will give this side. Minus will give this side, plus will give this side. So there can be a chance of net equilibrium here, but not at this point. That's why d plus r1. R1 is this distance. You got the point? Next question is, shows the electric fields around 3 points charges ABC. ABC. Okay, fine. What which charges is positive? Positive. A is positive because electric field is coming out from here. Going inside, so B is negative. Going outside, C. So this one is positive and A is positive. C. Whenever charges goes outside, it is plus. Whenever charges come inside, it is negative. Simple logic. Which charges has the highest magnitude? So highest magnitude will be the one which has most incoming lines. So B is how many? 1, 2, 3, 4, 5, 6, 7. 7 incoming or outgoing, depending on the 3, 4, 5, 6, 7. Here 3, 4, 5, 6, 7, 8, 9. So C is the most intense. In which regions of the picture could the electric field be 0? Net electric field can be 0. This is plus. This is minus. Okay, it is whole in the 3-point charge only. This is plus, this is plus, this is minus. Okay, electric field you want 0, you want to enclose, just enclose it. You will find an electric field. Near A, no way. Near B, no way. Near C, nowhere. Nowhere only is the option. Because they are not at same position. 5 charges placed here. What will the electric field is 0, 0, because all are like cancelling. Okay, one second. In the case of regular shapes, in regular case shapes generally it is 0, but yeah, it will be 0 in case of regular. Yeah. What to the electric field is 0, the charge from one of the corners say is removed. Okay, charge from this one is removed. So see, let me guide you. KQ by R square is this one. KQ by R square is this one. Same. In this one also KQ by R square will come from here. KQ by R square will, see, these two are, see, if it is divided by symmetrical on this will cancel out this. So net will be here because of this two. And this will be same as this, will be same, so the net will be here. So in A option, in 1, only KQ by R square. Here net is 0. See, effect will be only of A. Here will be minus KQ by R square. How would answer it? Because the n side of the polygon is okay. If n is odd and even, that is the main thing. If n is odd, uh, if it is symmetrical to 0, if n is even, because of only one will be there, so KQ by R square. Next is long answer. How much is that? 25, 31, minus 26. 5 questions are left. So yeah, this we will be talking about it in the next video, in the long answer one. So, or should we cover it now? These are long answer. Actually, it will take times. The previous one was short and only conceptual, so this will take times. So we will be covering this in the next session. Thank you for connecting to me and listening to me. We will be connect shortly regarding the next 5 question electric charges and field. I am Kush Anchalia from NITK, and we thank you for listening to me and have a great day ahead.